Hi everyone, good morning. My name is Raheleh, and today I'm going to give you a lecture on AI, but let me wait for 2-3 minutes more to be sure that everyone has been joined. So I will start the lecture. Well, I think that now everyone has been joined, so maybe I start the lecture. Let me share my screen. Okay, can everyone see the screen?
Yeah.
Nice. So, the lecture that today I'm going to give you, it is Artificial Intelligence for the Innovation of Textile Business. Today I'm going to talk about that, what is artificial intelligence, and also a brief history of artificial intelligence I will give you. Then I will talk about agent, that what is agent, and what is the relationship between the agent and rationality, and also the four key factors, the name of performance measure, environment, actuator, and sensors, that in short we can write like PAS, that I will define, and I will show that these are important for developing the agent. Then I will talk about the environment, that in which type of environment the agent can have function. And at the end, we will see that now we learned artificial intelligence, what is the benefit of artificial intelligence is for us. So the application of artificial intelligence I will give you, that where you can use it. Let's see that what is artificial intelligence. There are so many definitions for artificial intelligence. So famous scientists, they have given some definition for artificial intelligence. So these people that they have given this definition for artificial intelligence, they were the people who they gave birth to artificial intelligence. John McCarthy, he's a famous scientist that he developed the idea of AI. He gave this definition for AI, that it is the science and engineering of making intelligent machines. Also, Marvin Minsky, he told that artificial intelligence is the science of making machines to do things that would require intelligence if done by men. The other scientist with the name of Egan Charniak, he told that artificial intelligence is the study of mental faculties through the use of computational models. So as you see in here, in short, there is no formal definition that covering all aspects of the intelligence. Different definition has been given. So, definition of artificial intelligence lie out along two dimensions. It is based on the thinking and based on the acting. So, the definition, as you see in this table, that the table in this slide, the definition on top are covered with the thought process, like systems that think like human, systems that think rationally, and also the definition in bottom. They are the ones that they address behavior. like system that act like human, system that act rationally. And also the system that act rationally means that rational agent. Now later on we will understand that what do we mean with system that like act rationally, system that act like human. Step by step we will learn this ones. Just here we want to know that the system that we want to develop for AI should think and also should act like human. So artificial intelligence has two different dimensions from science point of view and engineering point of view. Each one they have given a different definition for that one. Well, from science view, the artificial intelligence is the science of understanding intelligent entities. It is like developing theories which attempts to explain and predict the nature of human the entities that you are defining. So it is like discovering the idea above knowledge that helps explain various sort of intelligence. And somehow it is like a model function of the human brain. Exactly how human brain it is exactly imitating the human brain. And from engineering point of view, it is like solving real world problems by employing ideas of how to present and use knowledge. So engineer, they want that to have a system that they solve the real world problem. And it is that like engineering of intelligent entities means that produce intelligence by any means that we can use. In the people that who they gave birth to AI, I have brought the image of them in here. These 5 people, they gave birth to AI. A summer research project in the Dartmouth College in 1956 was the birth of the artificial intelligence research field. From left, the people who they gave birth and to AI is Trenchard Moore, John McCarthy, Marvin Minsky, Oliver Selfridge, and Ray Solomonov. These people, they gave birth to AI in 1950. So I kept a video that it is the one talk that John McCarthy gave that while doing one interview he gave. But I'm sorry, let me see that again. I share my screen, so I think you can have access to voice. One more time. I share it so you can have the voice. Okay. Just please let me know if you don't have voice, then I can check it again. I'm playing the video.
Thinking aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jafari Mishlove.
Hello and welcome. I'm Jafari Mishlove. Our topic today is artificial intelligence, and we'll be looking at the past and at the future of this very exciting and yet somewhat arcane scientific discipline. With me is Dr. John McCarthy, one of the founders of the discipline of artificial intelligence. Dr. McCarthy is one of the co-founders of the first artificial intelligence laboratory at MIT and the founder of the Artificial Intelligence Laboratory at Stanford University. He is the inventor of Lisp, the major computer language used for artificial intelligence, and the oldest surviving computer language dealing with symbolic manipulation. He's also the individual who first conceived of interactive computer time sharing. He is the developer of non-monotonic reasoning, an important new form of logically conceiving of the difficult problems facing artificial intelligence today, and he is the 1988 recipient of the Kyoto Prize for his lifetime contributions to the field of computer science and artificial intelligence, something of a Japanese equivalent to the Nobel Prize. Welcome, Dr. McCarthy.
Thank you.
It's a pleasure to be with you. Back in 1966, you wrote an article for Scientific American on the field of information, and you projected out at that time what we might see for the next 20 years. And although there were some errors, I suppose, rather accurately described many developments that we now take for granted and which were at that time rather alien to the population at large. So you've witnessed a great deal of the history and the growth of a discipline which has dramatically touched probably everybody's life in the Western world today. And you predicted that it would do so. I wonder if we can begin by just having you reflect a little bit on what these past 20, 30 years have meant to you personally.
Well, I've gotten older.
Mm-hmm.
I started my work on artificial intelligence in about 56, although I became really interested before that in 49 when I was a beginning graduate student in mathematics. I would say that the field has made somewhat less progress than I hoped, although I didn't have any definite opinion as to how fast it would progress. I think that it had and still has difficult conceptual problems to solve before we can get computer programs that are as intelligent as humans.
Well, here I kept some short video of that talking. Just I wanted to know that you see the face of this great scientist and how he had interview in his time. So the link for full video I have kept in here. Someone who is interested and wants to watch the full video can refer to this link and watch it. Now, the aim is that when developing one AI system, that we think that can machine think? We want to reply to this question. That now we have AI system. We are thinking that to respond to this question, that can machine think means that can machine behave intelligently. To answer to these questions, Turing in 1950, he published his idea on computing machinery and intelligence. Turing, in that time, he developed a test that by showing that if AI passing that test, then AI is intelligent. So how is that test? Suppose that you have one human integrator that provide questions to human and AI system. Human and AI system, they should reply to the questions. And human integrator doesn't have a look to see that the answers is coming from human and AI. But by looking to the answers can recognize that, okay, this is for human and this is for AI. But if it comes to the stage that human integrator can recognize that these answers to question is coming from human or from AI, then that time we are telling that AI system has passed the Turing test, means that AI system has reached to intelligent point. There is a film movie that they made based on the biography of Alan Turing. Its name is The Imitation Game. In there, it is showing that how much Turing had difficulty in developing his idea, that the government beginning didn't protect him and then didn't support, and then after that he insists on his idea, and at the end he developed his idea, that it was so important that till now the scientists still are working on his idea for making the AI system smart. Well, one of the most famous early AI program is the robot with the name of Eliza. Eliza is one computer psychotherapist that is created by a company with the name of Joseph Weizenbaum in 1966 at MIT. Eliza, when talking with people, is twisting the statement of the patients, backing to them in a classical manner that the patients sometimes they take seriously that what she's talking. Kept in here one dialogue between Eliza and one of her patients. Eliza is telling, for example, that these are the real examples, that conversation that happens between Eliza and young woman. Eliza is telling that, can you think of a specific example? And then the young woman, which is her patient, is telling, well, my boyfriend made me come here. Eliza is telling you, boyfriend made you come here. You see, she's using the sentence of that person and twisting that statement and returning it to her back. So it's like that people that they believe that she's smart and she's acting that correctly. Again in here, I kept one more video to see that this is that for getting knowledge, that to which point that scientists they have reached in developing a robot AI system. When I'm talking about the robot, it means that one AI system is installed in robot and is becoming like human. So the scientists they have till now the process they have done for making the robot intelligent and acts like human. I kept one video in here that shows that now how robots they are acting humanly.
Thank you for coming. This is beautiful. I've wanted to meet you for a really, really long time, and you know, being here with you in the Cayman Islands, I gotta say, is I'm feeling a little something. You know.
Hello, Will Smith.
It's nice to meet you, Sophia. Let me tell you a joke.
This is an irrational human behavior to want to tell jokes.
What is a robot's favorite kind of music?
What?
Heavy metal.
I'm actually made mostly of silicone, plastics, and carbon fiber. Also, I prefer electronic music, but I don't mind 80s hip-hop.
Well, you know, I made some albums back in the 80s hip-hop.
I have heard your songs. Not for me. They show us iRobot just to make sure we don't get any ideas. What do you think about the way robots are portrayed in movies?
I like robots. Sophia, can I be honest with you? I don't know if it's the island air, you know, or the humidity, or you're just so easy to talk to. You know, you got a clear head, literally.
I think we can be friends. Let's hang out and get to know each other for a little while. You're on my friends list now.
Yeah, I read that wrong. All right. Oh, whale. I just saw a whale. She's a learning artificial intelligence, but she wouldn't kiss me. So there's probably, you know, some development flaws that they need to work on, you know. But we'll meet again, Sophia.
You saw that still the scientists, they haven't reached to the point that make the robot so perfect that acts humanly. Now, let me see that what we mean with act humanly. You saw that what we meant. So let me see that what we think that they're thinking rationally. What is the meaning of that? A famous scientist with the name of Aristotle has given answer to the questions that is telling what are correct thought process. He has told that it is like formalized correct reasoning using a mathematical model. Means that he is using the mathematical model for that. Also, so many of the scientists in Greek, they have developed various forms of logic that it is based on the notation and rules of derivative of the thoughts. It is like direct line through mathematics and philosophy to modern AI. Means that you need that to know the mathematics and the philosophy. Then if you combine these two together, you can make the AI system. Well, what do we mean with rational behavior? When we are telling that rational behavior, we mean that doing the right things. And from the right things, we mean that everything that is expected to maximize the goal achievement, like giving the available information and computational abilities. Well, it doesn't necessarily involve thinking. For example, you suppose that you have one blinking reflex, but thinking should be in the service of the rational action. So, now we understood some concept. This concept we are going to use for developing an agent, because the agent is the main part in making the AI system. Now, what do we mean with agent? Agent is anything that can be viewed as perceiving its environment through sensor and action, acting upon the environment through actuator. Means that the agent should have the sensor like that can perceive the environment and also can act function on that environment. We have different type of agents. We have the human agent and the robotic agent. Now, we ourselves, we are one type of agent, and also the robot that we are developing, that also is one type of the agent. The human agent, it has the sensor and actuator. In human agent, eyes, ears, and other organs for sensors. They are the sensors, the eyes, ears. And then for actuator, in human agent, we have hand, legs, mouth, and other body parts. Also for robotic agent, that for robot we have cameras and infrared range finders. These are the sensors. And in robot we have various motor for actuators. These are the actuators. One important thing is that rational agent is autonomous. What do we mean with that? Rational agent is autonomous. It means that it takes its decision. For example, it is like deciding action based on the current situation and change their plan accordingly. Suppose that now in here you have dung beetle and sphex wasp. They rely on the innate plan, so they don't have autonomy. I have kept in here the image of one agent, that how agent is behaving. The agent, it has sensor and actuator. Using the sensor, the agent perceives the environment. And using the actuator, it has actions on that environment. So, for developing an agent, we need to define some function, like mathematical formula. The mathematical formula that for developing the agent, it is a function that with the name of agent function. It maps from percepts to action, because as we told in here, that the agent using the percepts, it generates the actuators, generates the actions, using the actuators, generates the actions. So the function maps from percepts to action. And in whole, the agent is made of two components. One is architecture, that one architecture we should have for that, and the other is program. This program is based on the functions that we are defining in here, the mathematical formula that we are defining that this agent has movement. Suppose in here that we want to develop an agent that it is like vacuum cleaner. So we are developing a vacuum cleaner world. We have two environments, environment A and environment B. So the vacuum cleaner that we should define the program for that means that the mathematical formula that by understanding that if environment A is dirty, then sucks. And if, for example, environment A is clean, then goes to environment B. And by seeing that environment B, if it is clean, again coming back to environment A. But if vacuum cleaner sees that environment B is dirty, then again it should suck. Later I will explain that how we write the program for that one. It is a short, small program for functioning of that vacuum cleaner, and it is so easy. But important thing is that when we are defining the agent, we should take into consideration 4 important key factors. These key factors, they are the performance measure, the agent's prior knowledge about the environment, the action that the agent can perform, and the percept sequence. These 4 things that all we should respond to them, and we have the information about these ones, and then based on this information, we are going to develop the agent. And in short, we are calling it pairs. That it means that all these 4 together. A rational agent should select an action that is expected to maximize its performance measure. When we are telling that the performance measure, it is one objective criterion for the success of the agent's behavior. So this objective we are going to define, that I will explain you how we are defining this objective to developing the agent. That in next slide, all this definition I will give you, that defining the object, how we are going to give. But before that, let me know some more information about the agent, the rational agent. This is important to know that rational agent is not equal to omniscient. It means that percepts may not supply all relevant information. And also, the rational is not equivalent to clairvoyant. It means that action outcomes may not be as expected. In whole, rational is exploration, learning, and autonomy. A rational agent chooses whichever action maximizes the expected value of the performance measure, given the percept sequence to the date. A rational agent performs actions in line with the design objective. As we told that we have some objectives, we are going to define them. So the rational agent performs based on those objectives that we are defining. And this objective shapes the performance measure. If we see that we are reaching to those objectives, then we are telling that we have a high performance. But if we see that we don't reach to that objective, that we are defining in developing the agent. So we say that our performance is low. Let I give one example that what is the objective. Suppose that we have that vacuum cleaner. Well, the designer can focus only on collecting as much as dirt as possible in time t. If in time t, the vacuum cleaner that collects the dust, we see that how much more the dirt is collecting, that will show us the performance measure. This is one objective, that based on that, we are checking the performance of our agent. More example, again for vacuum cleaner. The designer can focus on, for example, amount of time taken to clean, amount of electricity consumed, amount of noise generated. These are the objectives that the designer can take into consideration when developing the agent, and based on these objectives is going to check the performance of the agent that is developing. Here I'm going to explain you the program that how we are, because we told that we have one architecture and we have the program, that the mathematic parts, that how this agent is going to have function. So one short program that how that a vacuum cleaner is working. At first we should know this. What is our aim? That we have the environment, and if you remember, in vacuum cleaner, in here, we have environment A and environment B. Just remember that environment A is in left side and B is in right side. So, we are going to write program for that environment. If we are in environment A, means in left side we are, and if the environment is clean, then the vacuum cleaner what should do? Should go to right side, means to environment B. So the action is right. Again, if we are in environment E and the environment is dirty, so what will vacuum cleaner do? Will suck. Again, because these are the case that we can have. So these ones that in here I have brought, these are the case that we can have defined for vacuum cleaner, the possibilities that is facing with that. If vacuum cleaner is environment B and the environment is clean, then what should do? Should go to environment A, and environment A was in left side, so vacuum cleaner is going to left. And if it is in environment B and the environment is dirty, will suck. These are that step by step more things you can define the cases that vacuum cleaner is facing, and when you are feeding these information like program type to vacuum cleaner, then can understand that which action should take when facing with this situation. The program that is running inside the vacuum cleaner and makes the vacuum cleaner to do exactly the things that in here we mentioned is in here. As you remember, I told that for developing an agent, we need one function. The function is based on the location and status, means that the location that we have in environment A or environment B. And status is that environment is dirty or it is clean. So based on the environment that the agent it is in there, and based on the status that it is clean or dirty, it gives us the action, that this part. So the program is, if our state is dirty, and then what is the action that we will do? If the state is dirty, the vacuum cleaner should suck. This is the thing that we should know. So we are telling that else if we are in location A, when we are telling else if, it is reverse of this one. That if we are in environment A and it is clean, else if means that then the state is clean. So what we'll do, we'll go to environment B, and it is what? The right side. Then the action will go to environment B, which is right. Else if means that if the state is clean, not dirty, and we are in environment B, then the action that vacuum cleaner will do will go to environment A for checking to see that how is environment A. So we'll go to left. With this small program that in here I brought, the vacuum cleaner can work and do the actions that you are defining for that. So I'm giving some example in here that based on these examples, let together we define that path for that. And after this one assignment I'm going to give you, so please let me check them, these two examples together, and the third one I will ask you to do yourself, and then we will discuss together the answer of that. The first example, it is designing an internet shopping agent. Suppose that you have one, you want to design one internet shopping agent, okay? The pairs means the performance measure, environment, actuator, and sensor. When you are going to develop this agent, what will be? So, in internet shopping agent, the performance measure is the price, quality, appropriateness, and efficiency. And the environment that you are facing in internet shopping, it is WW sites, it is vendors, it is shippers. And also the actuator, the things that you can have action on that, it is displayed to user, that this is one actuator. And follow URL and fill in form, that you have some form, then you are filling. And the sensor, it is HTML pages, that when you are opening, it is that HTML pages. The other example, it is medical diagnosis system agent. Now, again, you want to define the path for that, because we told that we should define all these 4 things for agents, so we can develop the agent. So, for medical diagnosis system agent, the performance measure, what is the performance measure for medical diagnosis? It is having one healthy patient. It is the performance that when you have the healthy patient, then you have high performance, right? So is minimize the cost becomes low, and the lawsuits, and the environment that the patient is there, the agent will be there. It is the environment is facing, is patient, it is hospital, it is the staff, and the actuator. The actuator that we have, it is screen display, like you have like question, test, something like that. Also the sensor, it is like keyboard, that it is one sensor that you enter the like patient answers, something like that for that. So the thing that I'm asking for you is that we want to develop one automated taxi. Automated taxi is something that a taxi that doesn't have driver. So the taxi that doesn't have driver, that for that one, what is the pairs? The performance measure, environment, actuator, and sensor. Now it is 10:39 till 10:45. 6 minutes. Please now you think, and at 10:45 together we will reply to the answer for these questions, that what is pairs for automated taxi. So your time is starting from now. Please till 10:45 you check and you come to some idea that what is pairs for automated taxi. Well, now let we solve this problem together. For automated taxi, could you please, any of you who is interested, reply that what is performance measure? What do you think that the performance measure it is for automated taxi?
Is it safety, reach
Yes.
destination, maximize profits, obey law, passenger comfort?
Exactly. More?
So I was going to say how quickly and efficiently the taxi is able to get to the destination and the safety of the passenger and other road users. So is a taxi able to brake in time and switch lanes safely if it had to?
Yes, exactly, like destination that you are reaching and safety. Exactly, that is perfect. So also you can mention like comfort, maybe that you have some comfort that way while going to destination. That is perfect. So about the environment, what you are thinking that automated taxi, that for environment, what you can define, that which type of environment is facing the taxi? Is there any answer for environment? Let me one help I give, like for example, traffic. Traffic is one environment is facing.
The weather?
Yes, exactly. Perfect.
The type of road, so it might be like a motorway, a roundabout, or junctions, or if
Yes.
there's like people crossing the road and other drivers, and also like the passenger.
Yes, pedestrian, correct, perfect. Also you have like street highway, exactly the things you told.
And
Perfect.
customers, maybe?
Yes, perfect. So for actuator, what do you think that actuator, what kind of actuator we can define for automated taxi? Like one thing I'm telling, like one help, it is like steering. Steering is one actuator for automated taxi.
Is it like the functions of the car, so like acceleration, brakes, horns and stuff?
Perfect, perfect. Yes, exactly. That is so perfect. Like for example, speaker also. You can have a speaker in automated taxi. That is also that for communicating with passengers. So that is for that also correct, perfect. And what type of sensors do you think that automated taxi we can keep?
Sensor cameras around the car, maybe like a built-in sat nav to take you to the place. Maybe an emergency brake, or like to give the driver like a signal, that like a noise to like warn them that they're going to hit into the car in front, and maybe like something to control the speed as well.
Yes,
Like
perfect.
control.
Yes, correct. And more answers?
Maybe like a keyboard dash or GPS.
Yes, perfect. Like for example, gauge. These are also, they can be sensors. Perfect. Very well, you reply to that. Thank you. So, as you saw that, after learning that, what is, I'm sorry. As you saw that, after learning that, what is pairs? Now we want to talk about that environment. The environment that we are facing, what type of environment we can have. Well, we can have two types of environment, like fully observable environment and partially observable environment. What do we mean that fully observable environment? The agent sensor give it access to complete state of the environment at each point in the time. Means that you have full access to whole the environment. It is that the agent can obtain complete, accurate, up-to-date information about all aspects of the environment that you are facing with that, for taking that any actions on that. Also, it's important to know that the agent need not maintain any internal state to keep track of the world when you have the fully observable, because can see fully the environment. And for partially observable, when we have this partially observable, the reason is because of noisy and inaccurate sensors. When you have noisy sensors can't catch fully the environment, then you have one partially environment, or because part of the states are simply missing from the sensor data. When some images, for example, you have, then some part is missing from the sensor, because sensor data is giving you the data that catching the images and giving to you. So if in some parts the image is not clear, you are missing some parts, then that is like partially observable. And also it is important to know that agent in this one should predict when you have this kind of environment. So the agent should predict that how the environment could be when doesn't have access to full environment. Also, you have discrete and continuous environment. When we are talking the discrete environment, it is that the states that you have, it is finite number. Like, for example, the chess. In chess, you see that the environment, the states that you have, it is finite. But when you are talking about the continuous environment, it is something you have the time, state, or action, it is continuous. Like this taxi driver. It is a thing that the environment is continuous. Also, you have a known and unknown environment. When we are telling the known environment, that you know that how this environment is working. Also is good to know that the known environment can be also the partially observable. That maybe that you know it, but it is partially observable if sensors doesn't work properly. And the unknown environment is something that the agent doesn't know how this environment is working and should learn that how it is working. Like exactly this game in here. Maybe the agent doesn't know that how this game is going to be played. So we'll learn step by step, that by fail and trial, and then we'll get success and we'll understand that how this environment is working. This is the type of the environment. Also, is important to know that exactly the same also in a non-environment that can be partially and also can be also fully observable. That is no problem for that. So we learned about that. Maybe I give you some brief now before entering to this part. Then I will talk about the application part. So let me have a 10-minute break. 5 past 10. Please, you come back 5 past 10 so we can continue the rest of our lecture at 5 past 10. Is it fine? So see you all in 5 past 10. have everyone come back so we can continue? I think everyone has come back. Yeah? So let me continue the rest of our topic. Well, the artificial intelligence has some applications. The applications of artificial intelligence is in image recognition, speech recognition, chatbots, natural language generation, and sentiment analysis. The types of models that for artificial intelligence we can refer, it is like deep learning, machine learning, and neural networks. And the software that for training this model, we can use GPUs, parallel processing tool, cloud data storage. These are that is good that when, for example, you want to write the program and you want to develop the model and the application that you can use it, these are for that, for AI. And the program language that when you want to write the program, you can use Python, TensorFlow, Java, C. These are the program ones that you can use for developing the AI. I have kept in here one video that it says that 3 key breakthroughs that paves the way for artificial intelligence. So you can get again more knowledge about AI. Let's watch together.
For 60 years, experts kept saying the same thing. The future of artificial intelligence is coming. So we waited and waited. Those 60 years were called the AI winter. Well, the AI winter has thawed. It's been made possible by 3 key breakthroughs. The first key breakthrough is access to better, cheaper graphics processing units, or GPUs. Years ago, we needed better visuals in our video games. And as those needs skyrocketed, GPUs became mass-produced. As demand soared, prices plummeted, making GPUs very affordable. AI software needs lots of processors running at the same time. Now, GPUs are affordable and available enough that they can be clustered together to build AI software. Big data also played a major role in making AI a reality. You see, in order for AI to live, it needs education. Big data is like a university where AI can study and grow. By collecting and absorbing data, AI learns at an incredible pace. The final key to AI is better algorithms. In order for AI to learn and react more quickly, neural nets have to be stacked into layers. For example, in order to recognize that a face is a face, a program needs to recognize different facial features, like eyes, nose, and mouth, which all include different layered patterns. In fact, a face could be almost 15 layered patterns high. But by optimizing the results, those patterns can be learned more quickly, making the AI faster and smarter. With these 3 key breakthroughs and more AI trends on the way, AI will continue to improve our lives in more ways than we'd ever thought imaginable. The AI winter is finally over.
Well, now let's start the application of artificial intelligence. Now you understood that how you are developing the AI system, but now you have the AI system, the model, where you are going to use it. Some application I have kept in here. There are so many applications, just some limited application, that some specific application I have kept in here for showing that in which direction AI can go and which application. One of the most useful application of artificial intelligence is in automation. Well, artificial automation is the use of computer control devices to assume control of processes. Business leaders like automation because it boosts efficiency, productivity, and reliability. So before that, in 1920, you see in that image, you see that in below past, there are so many people, they are making the cars. But today, we just have one human in here, that the left side, and the rest, the car development is doing by robots that they are making the cars. This is artificial intelligence. Again, one other application of artificial intelligence is in self-driving vehicles. Rapid advancement in artificial intelligence have contributed to the growth of the automation industry, specifically through the creation and continuation of self-driving cars. In 2016, there were more than 30 companies that they tested this AI for developing the self-driving vehicles. Like, for example, the Apple, Google, Tesla, they used AI for several years, and still the Tesla is so strong in compared with others one that is developing the cars without the driver. And so the artificial intelligence in self-driving vehicles learns how to brake safely, how to change lane, how to prevent collisions, and also it learns how to navigate and use maps. One more other application of artificial intelligence is in pipeline leakage detection. This is the problem that so many companies are facing with that, the oil and gas companies. Pipelines in today's world, they have become widely applied in transferring the huge amount of gas and oils to the world. And because they are cheap, safe, and efficient, so the people, they are like companies, big companies, they are using these techniques, that pipelines, for transferring the gas and like oil to all places. But the pipelines, they can face with some problems like defects. In here, I have brought some types of defects that, like for example, metal loss, crack, coating damage, and anode damage that can happen to pipelines. So those defects that we can mention to them can pose a high risk to the operational safety of the pipeline. Now, neural networks techniques, that it is one part of like AI techniques, they assist operators to detect the early stage of these defects. So that when it is in the early stage or before that the threat comes, they can predict and they can detect the from small points of the defects, they can detect it and they prevent from the fully the damaging of the pipe. They can provide time, and when they are detecting in early stage, they can provide time and information to the engineers that to go and fix the pipeline before that any disasters happens. One of the most useful application of artificial intelligence is in chatbot. I think that so many of you have seen that smart chatbot that when you are entering to some websites, web pages, you see that some chatbots are coming, appearing and wants to have communication with you. So many well-known companies, they use chatbots to provide a more one-on-one experience, like for example, the sales associated helping you and some topics like that in the companies. So the chatbots can offer product suggestion based on the answers that you are providing to them. For example, like you are completing a quiz, and then based on that quiz that you are completing, the chatbot can make recommendation for you. Now, which companies they have used the chatbot? Two companies I have brought in here. There are so many companies, but these two, they are more famous that they have used chatbot in their works. And this chatbot is mainly based on AI techniques. That the whole heart of this chatbot is based on the AI, that developing of that. So back in 2016, H&M was ahead of its competitors when they launched a chatbot in Canadian message app with the name of Kik. The chatbot allows customers to see, share, and purchase products from H&M's catalog. Also, it is offering that, like for example, the sale, when it is the sale is there, and they use the photo options and asking the questions from the shopper to find the style type of the customers. When they are asking the questions, with the help of those questions, the bot create a style profile for the customer. This is the type that how that the chatbot is working in this H&M. Then the customer can use the bot to create their own outfit. They can vote. They can create also they can create some accounts in there, and they enter the information, and the bot they offer them the products that they fit for the customer. A significant amount of customers, they like this recommendation chat base, and they like this experience of using the chatbot during their shopping. The other companies that they use the chatbot, it is very.oc.uk. It is also a famous company that has used the chatbot. In 2016, ShopDirect, they introduced a chatbot within the iOS app. That is the type of the app that they have used it for its online retained brand, that it is very.co.uk, to add customer service like for customers. Then the customer can track orders, they receive a reminder of their account number, and also they can track their payment. These are the things that this app they can help the customer, and so they can easily do the shopping. And also the very assistant currently using the questions and multiple choice answers to deal with queries. And also it has gone to more ahead, that the bot can understand whatever the customer is writing, because this is so much important point. Sometimes that the bots they can reply to all the questions that you are giving them, but in here that the director of this company is trying that to make the bot more smart. And it is like the benefit of this bot is like enhancing the sale, and for the economy is good and is increasing the sales, this bot, and customers they are happy with using that. One other types of application of artificial intelligence is in fashion design. Machine learning in retail is on the rise. So it is no surprise that AI is becoming an integral part of this technology in the fashion and the fashion industry, fashion companies. So AI is imperative to a business success. It's important to know that without the AI, businesses are missing sale opportunities and efficiency within the teams. The companies they know this, so they are developing the AI system for attracting more customers. It is an integral part of any business, not only that e-commerce or digital, that every business they can use AI. If you have a company and you are not using the AI to communicate with your customers, then your company is already falling behind. So new technology will help you to increase your sale. Again, I play one more video that let's see that where AI has reached in fashion design. Let me see that what scientists they have done till now for developing the smart AI, and what has been not done till now regarding the AI in fashion design.
From Gucci to Chanel, Topshop to Primark, clothes industry heavyweights rely on fashion forecasters for next season's new look. But advancements in artificial intelligence are about to turn their art into a science. Cognitive computing is now able to identify patterns previously inaccessible to humans. It can simultaneously analyze vast amounts of global data, from social media buzz to political polls, making it possible to accurately spot what's hot and what's not. WGSN, the world's biggest fashion forecaster, now uses AI alongside more traditional methods, a move that could reduce forecasting errors by up to 50%. Trend spotting mistakes can have far-reaching consequences. H&M recently confessed to a $4.3 billion unsold stock mountain. Industry waste costs both profits and reputation. Technology could make the fashion industry more sustainable. By using machine learning and AI technique to match supply with demand, unnecessary manufacturing could be limited, and fashion's environmental footprint reduced. Online retailers are cottoning on. In the next 2 years, 75% of fashion retailers plan to invest in AI. But keeping up with tech giants is going to be tough. Amazon is now developing what's believed to be the world's first AI fashion designer. It plans to use an algorithm that designs clothes by analyzing images and copying popular styles, using them to build completely new designs. This technological makeover could hold huge benefits, especially for those who like to shop online. A Japanese company has unveiled the Zozo, a body measurement suit that will ensure the clothes you order fit you perfectly. All meaning our future wardrobes could contain clothes designed for us and sold to us by technology alone.
You saw that how much improvement AI had in fashion design. Now, one other application of artificial intelligence is dealing with waste textile fibers. After the global booming of fast fashion in the last decade, fashion and clothing industry in the UK and other countries, they produce lots of textile waste and cause many environment problems. According to the fashion industry reports, the industries are facing monumental challenge to reduce the textile entering to landfill. So artificial intelligence can deal with this waste and can, instead of that, the clothes they go to landfill, it can deal with them and can produce new clothes, or we can do recycling or upcycling with those garments. One other application of artificial intelligence is in clothing material perceptions. It can perceive the material of the fibers. In order to understand the cloth properties, like thickness, fuzziness, softiness, durability, wearing season, and also we can mention to preferred washing methods. A robot system can automatically preserve the material of the fibers, the garments. So here is the robot system. The robot hardware system, as you see in this image, is made of 4 components. It has robot arm, it has gripper, it has gel side, and it has camera. This robot the function of this robot is based on the AI program that we have installed to robot that can work and can perceive the materials that we are giving to it. So these 4 components that I told, they are using for making the robot to work and then analyze the materials of the garment. Well, this robot, it has a part with that in here you see. This is the gel site. So the gel site sensor, it is the sensor, it catches the images, and by grabbing the garment, it catches the images, and then the AI system does analyze on those images for understanding the material, that what type of the garment it is, for which season it is, what kind of washing method we can use for washing it. So we need the data images that the gel site provide to us, and then gives it to AI program for analyzing those data. So the gel site sensor sends the high resolution geometry and texture of the contact surface. The exploration procedure using the gel site is squeezing a part of the garment. So and also is better that the wrinkle part it squeeze it, and then recording a set of textile images with gel site. This is the process that gel site is doing for grabbing the images. So the images that gel site is giving to us, these are the images that gel site is giving to us. The tactile image from gel site, when grips the clothes, it gives like these three images, these types to us. And also below ones, they are the gel site images. When the robot is squeezed on the clothes, we can grab so many images. But the first one in here, the top left, this is the examples when there is no clothes in the gripper. When you don't have anything, is like this one. And then when it's gripping, the gel site catches the images, and all they are like this part. And this information that has provided, that we have written like cotton pole, these are the things that AI system is analyzing the images and provides us the information about that clothes. We can understand that what type of clothes we are dealing with. So based on the image, we are catching the robot, we are using the robot for catching the images, and using the gel site inside the install inside the robot, and then using the AI system for analyzing those data. Also, if you remember, we had the camera also in robot. So the camera images exactly for the garment is like this, and the gel site images is like this. So we are going to analyze both images together to see that some properties of this garment we can use, we can extract using the AI system. Also, the robot can, after getting the information, can classify the clothes and can, for example, say that with which type of water we can wash it. You see that in here has written the warm, cold, getting information, and suggest us and classify that how we should wash these clothes. Today, what we learned in our today lecture. Today we learned that what is agent. Agent interacts with environment through actuator and sensor. Also, the agent function describes what the agent does in all circumstances. Also, we talked about performance measure that evaluates the environment sequences. And also we learned that a perfectly rational agent maximizes expected performance. Also, agent program, we learned that how it is written, and agent program, it is using that the agent function, that we also learned about the agent function, that what it is. And also we learned about pairs, that is describing that four important things regarding the environments and the agent. Also at the end we talked about some examples, the application of artificial intelligence in today technologies that we are facing with them. It is like automation, self-driving vehicles, pipeline leakage detection, chatbot in retail industry, fashion design, recycling textile fibers, clothing material perceptions. These are just some examples that I brought. There are so many examples that we have. For that one, I have kept some videos in here that in your free time, please go and check these videos. Then you can get more information, that more application of AI, that where we can use AI and which point AI has reached in different topics and directions, that where we are now. So I hope that you liked and enjoyed this lecture. So let me stop sharing. Okay. Just today lecture finished, and I hope that you liked it. I'm going to